Hello everyone, welcome to my YouTube channel Daily Dose. So today I've come up with an important and interesting topic of chemistry, the solid state. I'll be making two videos on this topic. So let's begin. So the contents are the classification of solids and properties of solids. Classification of solids. Well, solids are classified on the basis of two parameters, the packing of the constituent particles and forces of attraction among the constituent particles. So classification on the basis of constituent particles can be of two types, that is the crystalline solids and the amorphous solids. So crystalline solids. In these solids, the constituent particles are arranged in an orderly arrangement. They are also called as the long-range order solids. Amorphous solids, the constituent particles are not arranged in an orderly manner, they are randomly scattered. So it is known as short-range order solids. Crystalline solids have got a sharp melting point and the amorphous solids have got a diffuse melting point. So crystalline solids, they are also known as the true solids and they have got characteristic enthalpy of fusion. Whereas amorphous solids are pseudo-solids or supercool liquids and they have the tendency to flow. So they have no definite value of enthalpy of fusion. Next point is crystalline solids are anisotropic in nature. So what does the term anisotropic mean? So when properties of a material vary with different crystallographic orientation, the material is known as anisotropic. The different crystallographic orientations. And what does isotropic means? So amorphous solids are isotropic, and isotropic means that when properties of a material are same in all direction, the material is termed as isotropic. Crystalline solids, on cutting with knife, they give sharp edges, and amorphous solids, they form irregular edges when cut with a knife. Let us look at the examples. So examples of the crystalline solids are quartz, diamond, and examples of the amorphous solids are rubber, glass. So you can see the structures here. The red dots depict silicon and the blue dots depicts the oxygen atoms. So you can see the arrangement of the crystalline silicon dioxide and amorphous silicon dioxide. There is the quartz and the glass. So you can see the orderly arrangement of the atoms in crystalline molecule and crystalline silicon dioxide and the haphazard arrangement of the atoms in amorphous silicon dioxide. Okay, so let's move on to the next topic, classification on the basis of nature of intermolecular forces. So first we have got the ionic solids. So, what are ionic solids? The compound ionic solids is neutral overall but consists of positively charged ions called cations and negatively charged anions. So, there is a regular arrangement of these ions throughout the solids, and the ions are held together by these strong electrostatic forces. They are brittle and have got high melting point. They are soluble in polar solvents but are insoluble in non-polar solvents. Polar solvents such as water and non-polar solvents such as hexane. So when ionic solids are dissolved in water, the cations and anions separate. These solids have got high enthalpies of vaporization. Examples, the lithium fluoride and sodium chloride, etc. The next type of solid is metallic solids. So metallic solids, as the name refers, the solids are composed of metal atoms that are held together by the metallic bonds. And metallic bonds are like huge molecular orbitals that span across the whole solid. So as a general principle, we can say the more valence electrons there are, the stronger the metallic bonds they will be. And this means that they have got higher melting points. Well, you can see that metal cores, that is kernels, and a sea of mobile electrons are the constituents of metallic solids. Each metal atoms contribute one or more electrons towards the sea of electrons. These electrons are evenly spread out throughout the crystals, and metallic bonds bind kernels and sea of electrons. They may be hard or soft, having moderate enthalpy of fusion. They show malleability and ductility. So malleability, the metals can be beaten into thin sheets, and ductility means they can be drawn into thin wires. So they are good conductors of heat and electricity. So examples are copper, iron, and nickel. Then we have got the covalent solids. In the solids, atoms are bound together by covalent bond, as the name suggests, and covalent bonds are strong and directional in nature. These solids are very hard, brittle, and have very high melting point. Due to absence of any free electrons, they are insulators. Their enthalpies of fusion are very high. Examples are given down. And you must know an important point, that covalent solids are also called as network solids. As such, they have localized electrons, that is, they are shared between the atoms. And unlike ionic solids, they do not dissolve in water, and they are non-conducting in nature. So examples are diamond, graphite, boron nitride. Next are the molecular solids. Well, you can see the structures of the diamond and graphite above. So diamond has got sp3 hybridized carbon. Okay, and the graphite, you can see the carbon atoms, they are sp2 hybridized carbon atoms. You can see the arrangement. Well, the next type of solid are the molecular solids. Their molecules are held together by dispersion forces, dipole-dipole forces, hydrogen bonds, and on the basis of the type of interactive forces, they are divided into the following: the non-polar molecular solids and polar molecular solids. So what are non-polar molecular solids? Either atoms or molecules are bonded together by weak dispersion or London forces. And these are non-conductor soft solids with low melting point, low enthalpy of vaporization. Well, I've got some spelling errors there. Kindly ignore. And they are volatile in nature. Example, iodine and camphor. Polar molecular solids. Polar covalent molecules are held together by strong dipole-dipole forces, and these are soft, non-conducting solids with low melting and boiling points, which are still higher than the non-polar molecular solids. They have high enthalpy of vaporization. Example, ammonia and sulfur dioxide. The last one is the hydrogen bonded molecular solids. So polar covalent molecules containing hydrogen atom as positive pole and nitrogen, oxygen, fluorine as negative pole are held together by intermolecular hydrogen bonding. Under room temperature and pressure, they are generally volatile liquids or soft solids. Example, ice. As the name suggests, hydrogen bonded, there must be a hydrogen atom. So the next topics are the properties of solids. I'll be going in details in my next video about this topic. Well, you can see on the screen that I'll be discussing about the two types, the electric and the magnetic properties. So you can see the types, that is the conductors, insulators, and semiconductors. So please stay tuned for my next video to get updates on this topic. Thank you for watching my video.